Alright, this is energy forms and changes tabs. There are two tabs, intro tab and energy system tabs. Yeah, so let's click on energy system tabs. We'll come back to the intro tab later on, but first we'll start with this one. And this is not an iPod, though it looks like it, but this is kind of like a different forms of energy and how you can convert different forms of energy into different forms of energy. Okay, so let's click. There is a tab called energy symbols tab, and what that does is basically tells you how much of energy is there in a particular system. Okay, so you see that the energy is coming in or going out, so that you have a way of seeing it. Okay, this is an energy quantity control tab. You can control how much of energy comes in and goes. So this is basically a water tab. Yeah, so you can control how much of water is coming in. You can see that the more the flow, the more the energy is in, and obviously the faster the wheel will rotate. Okay, oops, give me 1 second. Okay, and there are different sources you can use. As the main source, you can use either sun or tap, a kettle or a bicycle, or you can the secondary source, you can change it to either a wheel or solar panel, and the output you can use as water, light, a bulb or a light. Okay, basically that will tell you. So if you change, let's say if you change this and then you start the tab, and so you should see that the light glows. Do you see that? Yes. Okay, so let's reset and start our experiment. Okay, so first thing, when you start the experiment, always make sure that energy symbols are selected. Yeah, so there are different forms of energy which is shown by different types of colors of energy. Okay, gray color is for mechanical energy, blue is for electrical, red is for thermal, yellow is for light, and green is for chemical. Okay, and we'll see how the energy changes when from one form to another form. Okay, so when the conversion control is set to paddle wheel, which is this, there is an electrical generator that drives the paddle. Yeah, uh, so that drives the paddle wheel, and so when the paddle wheel moves, yeah, the electricity is generated. Okay, so you'll see the electric energy flow. Basically, under the beaker of water is heated and it absorbs basically the electrical energy. You have a heater right here. Yeah, and this heater is going to absorb the electrical energy, gets converted into heat energy, and it will start heating the water inside. Okay, which can be seen by the temperature rise in this thermometer. Okay, alright, so now let's start our experiment with quantity control. You start this. Yeah, so you keep it right in the middle somewhere, I guess. You can see that the energy is coming in. You can see that this is a gray color, correct? This is a mechanical energy. It comes to the paddle wheel. There is an electrical generator which converts this mechanical energy into blue energy, which is electrical energy, correct? That electrical energy moves to the heater. You can see that it gets converted into red forms right here below the beaker, correct? As each of this energy comes in, you can see that it gets converted into red. So this heater converts this electrical energy into thermal energy. Yeah, and this thermal energy is now, you can see, heating up the water. You can see the temperature of the water going up. You guys see this? All these changes. Okay, so now you can see that the water is boiling. You can see the vapors. Yeah, the water has reached its boiling point, and there are more energy molecules now stored in water, correct? And the water has started boiling, and now see what happens. There are still more energy coming in. Water is storing this energy still. Yeah, the temperature is rising, and after a certain point you can see that the temperature is not rising anymore. Okay, and this is the boiling point of water. At this temperature, or at this point, the temperature is not increasing. You can see that the energy is actually, whatever the extra energy that is coming in is actually escaping. You see that? Yeah, so when this happens, the energy, the temperature is not rising at this point. Yeah, what is happening is this energy is being used to increase or to change the state of water from liquid to gas. Okay, so the energy is being used to transform the state of the water from liquid to gas, and that is the reason why um, the energy of the water is not increasing after this point. Do you guys see this? Is this understood? Clear? Yeah. Alright, so now let's do the reset. Alright, now use sun control as, so we use sun as the source of energy. Alright, so you can control how much cloud you have, how much cloud you don't want. Obviously, if you have more clouds, let's say, the sunlight is going to be less, correct? If you have more light, if you have no cloud, sunlight is going to be more. Yeah, obviously sun is not going to, sun has a light energy, and this light energy cannot be converted into heat energy by a mechanical generator, correct? You need a solar panel, and so we replace the solar panel, so we replace the wheel with the solar panel. Yeah, now second, we have energy symbols. Oops, so we forgot to turn on the energy symbols. Yeah, so you can see that the sunlight is coming in. It is, this is the light energy, correct? You can see that it is light energy, and see how it is like a particle, correct? Each of these is actually looks like a particle. It's like a little balls of energy falling in. So let's do the restart from, start from the beginning. Yeah, because it starts immediately, so it's kind of, I wanna see that you see the whole picture. Yeah, so you can see that this light comes in, it falls on this solar panel, which has which converts this light into, again, into electrical energy. Yeah, so something that this heater understands, right? Heater can only convert an electrical energy into heat energy, so you need to convert all forms of energy into an electrical energy. If you can do that, that means then heater can convert the electrical energy into heat energy, and that's exactly what is going on. Yeah, you see again the same process is going on. The heater turns on, you can see it gets red, then the heat energy is being stored in the water. You can see the temperature is rising. Yeah, and after some time, when it reaches a certain value, the water won't heat up anymore, the temperature won't go up anymore. Instead, you'll see the vapor comes out. Okay, that is the boiling point of water. That means now you have water energy is being converted into vapor energy. Okay, so you don't see a rise in temperature. Okay, let's wait. You can see the vapors coming out. Yes, Okay, clear? If you increase the cloud, obviously you can see this directly affects the amount of electrical energy that could be generated from the sun. Yeah, there's less light particles are hitting the solar panel, and obviously it's going to affect how much electrical energy you can generate. That means how much heat energy you can generate. Yeah, pretty cool, isn't it? Can actually see how the energies are getting converted. Yes. Okay, let's do the reset now again. um, Now let's use kettle. Okay, what does kettle do? It produces steam, it has a water in it. Yeah, and the steam should should rotate. Yeah, steam has a force, right? So it should rotate the wheel. So let's see if that is the case. We crank up at the heat, and so you can see that the heat energy is being used to boil the water, that produces steam that rotates the wheel. You can see how the conversion is taking place. Your thermal energy is being converted into mechanical energy, which is which will get converted into electrical energy, which will get converted into again thermal energy. Yeah, it's not a very efficient way of heating water, but you can. Now let's wait for a while. See, you should be able to see that increases the temperature of the water a little bit. Okay, it will probably take longer time here. In this case, as I said, it's not a very efficient way of heating up water. Yeah, so basically you are using heat. You are using heat first to heat water, and then that that is heating another water. Yes, it's kind of a very lousy way, but hey, people are stupid. What do you say? Correct. It's also, you can see that a lot more energy is actually escaping. Yeah, than that's getting converted. Yeah, so it's again, it's not a very efficient way. Is this clear? You can see the temperature is rising. So what is the purpose of this experiment, and why are we doing this? Anybody wants mic control? Want to speak up? What is the purpose of this? Can we say that heat is simply a form of energy? Yeah, this is forms of energy. Heat is just a form of energy. It's nothing much. It could be any of these. Yes, we can convert heat into any other form. We can convert heat into chemical energy. Chemicals actually have heat in them. Yeah, light also have heat. Thermal, it's a form of energy. It's nothing much. Yeah, it should not be confused with temperature. That's the point. The whole idea of doing this experiment is that people get confused with temperature and heat. Temperature and heat are totally different thing. Yeah, temperature is, as I said, is the average kinetic energy of the particles. Yeah, that's the measure of temperature, whereas heat is the aggregate or the total energy of the particles. And you can see that it's actually the energy is moving, and you see the energy is being stored. That's heat energy. Yeah. Oops. Alright, so this is being done. Let's reset the experiment. We are done with this energy system lab. Yeah. You can actually even use bicycle to do the thing. You can heat the water using bicycle, or you can light a bulb. And actually there has been I was seeing in the in one of the Discovery documentary or something. It wasn't a documentary, it was kind of like a series um, on some of the greenhouses in California area. Yeah. And there's actually a family that have kind of like a similar setup in their house in the basement. And what they do is every day everybody in the family is supposed to run it's supposed to ride the bicycle for 30 minutes in the basement, and the bicycle is obviously connected to some sort of mechanical wheel, and this is then connected to a battery where the energy is stored. Yeah. And so the guys and essentially the guys then use that energy to light up their house. Yeah. And so this is what they do every day. Everybody in the house does this for 30 minutes. Yeah. And that is their way of staying healthy. They get the energy in the form of light. You can see energy symbols basically here. Oops. Yeah, this is the chemical energy. Where does this chemical energy comes from? Where does this chemical energy comes from? Divyangi, Kirti, where is this chemical energy coming from? Yes, but where is it coming from? Do you see this click here? What is that? You can see that this is slowing down. Everything is slowing down. Yes. Yay, he's happy again, and he or she, I guess, I don't know. He's happy again, and she's riding the bike. Yeah, chemical energy gets converted into mechanical energy, which gets converted into electrical energy. Electrical energy gets converted into light energy. Question is, where is this chemical energy coming from? I just clicked feed me, correct? Divyangi? Yeah, feed me. What is that? Food, correct? The chemical energy is coming from food. We eat. Yes? Yeah, so so again you see that the energy level is low. That means you need to feed that person and he will ride the bicycle. So it's very unique experiment, gives you very intuitive. And so I was telling you about the guy who in California, yeah, so California area, who has this kind of setup in his house. And what happens is that they actually end up generating more energy than they need. Yeah. So they actually end up transporting the energy into the grid. Okay, they don't use the energy from the grid, they actually give back to the grid. And as a result of that, they actually get a negative bill for their energy consumption, not the positive bill. They actually get a negative bill, and as a result of that, they act every month from the California Board of Electricity, I would believe, whatever it is in there. They get a check every month, and it's a nice way. I think they also have solar panels attached to their house. They also convert solar energy into electrical energy. Um, but it's a nice way of being independent. Yeah, it's a nice way of making money, and it's a nice way of staying healthy. Correct? it doesn't really reset. I'll keep on going. Okay, now click to intro tab. Okay, so now we again check the energy symbols box. There are different things here. There are iron block, brick, there is water, and there are two heating mantles. Okay, now can you see the iron block and the brick are roughly equal size? Can you say that? Can you see that the energy levels or the amount of energy in each of them are different? Clearly iron has more energy in it, brick or energy particles in it. Brick has less energy particles in it. Yeah. Now, so you can take the thermometer from here, connect it. Basically I usually put it somewhere around here so that I can see exactly how many particles are in there. Take another particle, you connect it up here. Yeah, and now you can see that the temperature for both these blocks are same. I'll just put it somewhere around here. I guess it doesn't really matter. How is it? So I think it just has to touch the surface, or this arrow needs to be turned to that specific color. Yeah, so this is gray and this is red, that means this is connected. Okay, now can you see that the temperature is the same for both brick as well as iron? Okay, now let's take the iron block or brick block and put it on the top of brick, top of the iron blocks. Okay, now what should happen is, maybe it won't happen that fast. Okay, do you see any energy change in the temperature of these two? Do you notice any energy change? No, correct? There is no, probably should be about the same temperature. Yeah, so let's take this brick block, put it on the heating mantle or Bunsen burner, whatever it is, and use heat control, yeah, this one, to heat the block until the temperature rises to the max. Okay, so you just heat it. Just heat it. Yeah, up till the temperature rises to the max. Yeah, now we take the brick and then put it over the iron block and see what happens. Okay, can you see that the energy particles are going down? Can you see the temperature is going down on this side? Temperature is actually increasing on this side of the thermometer. The temperature of the iron is increasing, temperature of the brick is decreasing. Can you see that? Yeah, let's wait for some more time and see what happens. Now we clearly saw that there was a flow of energy from brick to iron. Yes, we clearly saw that, obviously. So just fast forward a little bit, I guess. Very slow. So we'll just fast forward. Can you see now the temperature is increasing? Some of the energy or some of the heat is getting escaped. I think let's put it side by side. Probably will work much better. Oops, I had a thermometer slightly up. Okay, so let's actually do the reset for this one. Is that a reset? Yeah, so let's do the reset. Yeah, I think it works better if you put it. Alright, so let's take the temperature here, take the temperature here, heat the iron block. Okay, you can see that now. Let's put it aside to the iron block. Yeah, in the previous class I had the temperature thermometer slightly on. Just put it on the same level so it will be easier to see. Let's do some fast forwarding. What is going on? Why is it? Okay, something is wrong here. It's not working the way it is supposed to work. Oops, yeah, that's what I'm saying. It's not the experiment is not behaving very nice. Oops. Okay, so basically what is supposed to happen is that the temperature of this brick should decrease and the temperature of the iron should increase. I can't see that. Yeah, so now you can see that the temperature of the iron has increased. Yeah, now it is behaving the way it is supposed to, and the temperature of the brick has decreased. Yes, and their temperature is near about same. This is slightly brick iron is slightly lower, but brick is slightly higher. If you leave it for some more time, you'll see that they will reach a same temperature. Yeah, it's really not behaving the way it usually does, but could be the problem is, I don't know, some other issue. Yeah, so that is what is happening. Okay, so you also saw that the heat transfer takes place between the objects, yeah, which is basically the energy transfer. You also saw that when that happens, there is some loss in energy, yeah, some energy was lost into the atmosphere, and that is common whenever there is a energy transfer or energy change. There is always going to be um, a loss in energy. Okay, only conductors and semiconductors that can use electrical energy. By creating electricals that use conductors, we can make sure that very little energy is lost. Okay, um, alright, so once there is equilibrium between these two energy blocks, you can see that there is no energy transfer now is taking place. You can see that they are at the same energy level, and there is no energy transfer that is taking place. Okay, so basically when they are at different energy levels, the energy transfer takes place. When they are at the same energy level, no energy transfer takes place. Is this clear? Is this clear, guys? Okay, let's do the reset. Yeah, my computer is not responding well today. Something is wrong with it. Okay, click reset. All right, so now we place one thermometer in the water. Okay, place one thermometer in the brick, and place one thermometer on the sand. Yeah, we make sure that the energy symbols are turned on. Okay, now we place the water on the stand. Okay, and now we so you can see that there is a lot more energy in the water than in brick and iron. Yeah, so there is a lot more energy in, even though they have the same temperature. Yeah, so you can see that their temperature is same, correct? Their reading on the temperature is same, yes, but the energy in water is much more than the energy in iron and brick. Yes. Okay, so let's put it on the stand. Alright, heat the water until you see a maximum rise in temperature. Okay, so yeah, it takes a little bit time to heat up, I guess. Let's do some fast forwarding. Yeah, you can see the temperature is increasing. Excuse me. Yeah, so that's probably the max it can reach. We use the pause button to stop the animation. It's not that. We take the whole thing, and now we heat. Oops, we need to play it here. So let's heat, and again we heat it until the temperature reaches maximum for the brick. Okay, again we may want to heat a little bit of this. Okay, and just press pause. Yeah, you can see now they're pretty much at the same temperature. Yeah, you can see how many energy particles are there in water, and see the number of energy particles in brick. still they have the same temperature. Okay. So what do you think is, if to reach the same temperature, which of these two would require less heat, water or the brick? Brick. Yeah, so basically that's the idea. It has less energy particles, so if you provide less energy, the the temperature should rise much faster. So it takes longer to so if you have a bigger container of water, it's going to take even longer to reach the same temperature. It's going to have more energy, but it's going to take longer to rise the temperature by the same degree. Okay, so that's the idea, that the temperature and the whole thing is actually quite different. Now let's actually cool the brick. Okay, I wish it was a little bit more faster. Okay, but that's wishing too much. Yeah, so now we reduce the temperature to very low. We heat this a little bit more, I guess. Okay, and then now we transfer the brick into the water. Yeah, and you can see what is happening. The temperature of the brick is rising, the temperature of the water is falling. Yes. Now it has reached an equilibrium, but you can still see that the brick has less energy particles, water has more energy particles. Yes, even though they have the same temperature. So this is a heat transfer. Yeah, so the heat is getting transferred from the water to the brick. Yeah, and as a result of that, the water temperature decreases, brick temperature increases. Is this clear? Yeah, so when there is an equilibrium, when they are at the same temperature, obviously this transfer of energy does not takes place. Yeah, now from these experiments the following points should be clear. First, when state changes, temperature remains constant. Yeah, we saw that when the boiling point was going up, yeah, or when the liquid was boiling, you did not see a rise in temperature. Yeah, so when the state changes from liquid to gas, there is no rise in temperature. Same should be the case with when the state changes from solid to liquid, there should not be a rise in temperature. Yeah, that heat that is required is called as latent heat. Okay, that is a latent heat. um, the temperature difference is required for heat to flow. When there is no temperature difference, you don't see the heat flow. Correct, you don't see if there is no temperature difference, such is the case is the now between the water and the brick. Yeah, there is no heat change, heat exchange between these two medium, these two substances. Yeah, so you need a temperature difference for heat to change. Okay, different objects need different amount of thermal energies to stay at the same temperature. Yeah, brick required less thermal energy, whereas water would require more thermal energy to be at the same temperature. Are these things clear? Yes. Okay, so that is our lab. So now we'll go and solve some of the questions in our class. Yeah.